Welcome to day 11. In this lesson, we'll explore a simple but powerful idea, typecasting, or converting one data type into another in Python. Think of typecasting as helping Python understand your data. Sometimes information comes as text, but we need it as numbers to calculate, compare, or process in an AI model. By the end of this session, you'll confidently convert between integers, floats, strings, and Booleans, essential skills for AI, data analysis, and real-world automation. Let's dive in and make Python truly understand your data. This slide explains what typecasting actually means. Typecasting is the process of converting a value from one data type to another, for example, from text to a number. It's like translating a message into a language Python can work with more effectively. Let's take an example. When you receive user input, Python always treats it as text. If the user types 5, Python sees it as the word 5, not the number. To do math with it, we convert it using float or int. So, when we write x equals 5 and then float x, Python turns 5 into 5.0. Now it's a decimal number ready for calculations. Typecasting ensures data flows smoothly between operations, whether it's text, numbers, or logical values. Now, let's explore Python's built-in functions for type conversion. Int converts data into whole numbers. For instance, int 3.9 gives 3, because Python removes the decimal part instead of rounding. If you pass a string like 42, it becomes the number 42. Float converts data into decimals. So 19.5 becomes 19.5, perfect for handling precise measurements or prices. Star converts anything into text. This is handy when displaying numbers inside sentences, like your score is plus star score. And bool converts data into true or false values. 0 or empty strings become false, while any non-empty or non-zero value becomes true. Together, these conversions give you total control over how Python interprets and uses your data. Here's a practical example that shows why typecasting matters. Let's say you ask the user for their age. When they type 25, Python still treats it as text. If you try to add 1 year, you'll get an error because Python can't add text and numbers together. To fix this, we use typecasting. By wrapping the input in int, like intAge, we convert the text into a number. Now Python understands it's numeric and can add 1, giving 26 as the result. This simple conversion is crucial in real-world programs, especially when collecting user or sensor input. Without it, your code may break. With it, your program feels intelligent and seamless. Now let's see how to convert string data into decimal numbers step by step. Step 1. Start with string data. We set price equals $18.99. Right now, this is just text, not a real number. Step 2. Convert it into a float. We write numeric price equals float price. Now Python sees it as a decimal, $19.99. Ready for calculations. Step 3. Perform calculations. For example, you can calculate tax or totals. Multiply the price by 0.2 to get VAT, then add it to the total. Typecasting turns plain text into actionable numbers, perfect for use cases like pricing systems, analytics dashboards, or AI feature perception. Here's where typecasting becomes truly powerful. When working in AI, machine learning, or data science, you often deal with external data, from CSV files, sensors, or APIs. This data usually arrives as text, even if it looks like numbers. Let's look at real-world examples. When reading CSV files, every value starts as text. You must convert them into numbers before analysis. When processing sensor data, Readings like temperature arrive as strings and need conversion to floats. During machine learning training, models expect numeric features, so we cast or encode text data into numbers. And when working with APIs, values that look numeric often arrive as strings and must be converted before use. For instance, if you're predicting house prices, a feature like 3 bedrooms or 150,000 must be cast to numbers before feeding into the model. Without this step, your AI model won't even start training. So, typecasting isn't just syntax, it's data preparation for intelligence. Let's wrap up with the key takeaways from this lesson. First, typecasting enables data conversion. Use int, float, star, and bool to switch between data types based on your task. Second, it's essential for mixing text and numbers. You'll need it whenever you're combining user input, file data, or display messages. And third, it's vital in real-world applications. From data science to web development, typecasting ensures your programs process information correctly and prevent type errors. You've done great mastering this fundamental concept. In the next lesson, Day 12, Checking Types with Type, we'll learn how to inspect and verify data types in Python, making your programs more reliable and smarter.